Hello everyone, this is a video lecture for Business Calculus, Math 1325, Section 10.1, Continuous Compound Interest. So this is an algebra concept, and I don't know why it's put here, but well, let's talk about it anyways. It is a cool and important concept. So A is equal to P times E to the RT, the PERT formula. Again, I'm just going to assume that you haven't ever seen this. So A is your final amount in the account, which I'll explain more about compound interest in a second. P is your principal, or again, your initial amount or your starting amount. E is a constant, 2.71828, and I can real quick prove that to you. E, there you go. So that's a constant, kind of like pi, goes on forever. So R is your rate, and this has got to be in decimal form. And then finally, T is time, and I believe it's got to be in years, but there we go. So compound interest is an exponential formula. It just keeps growing. Like your money keeps growing. You put sum of money into a savings account or a certificate deposit, and they're going to have problems kind of like that coming up. You put it in there, and you wait some time, and eventually you get a lot of money. There you go. That's it. I don't know what else. Let's go ahead and do it. So, yeah, there's your formula. Woohoo! So let's do the first problem. A is equal to 5,000 e to the 0.04 t. And they say t equals 4, and they got t equals 5 and all this other stuff. I just get bored with it. But plug it in and have fun with it. So, all right. So 5,000 e to the 0.04 times 4. Calculator. And that's it. That's the entire problem. And so I'm happy that the first problems are always kind of easy. It kind of makes you feel confident going forward. So 58767.55. Again, that's dollars. So zooming out, and again, this will keep going for 5 and 6 and whatever they ask. So zooming out, you started with $5,000 in an account, and you left it in there for 4 years at a 4% interest rate. And at the end of 4 years, you now have $5,800 in the account. So you gained $800 by doing nothing, by simply owning $5,000 and putting it into an account. So that's pretty cool. It's free money, kind of, but you have to have that money first in order to be able to do this. And I got to say, 4% interest rate's pretty good for a certificate of deposit. I mean, that's awesome. Anyways, not where we're getting at here today. So 10, 1, 13, we got 3 is equal to e to the 0.06 t, and they say solve for t. Like, that was it. Go ahead and figure that little equation thing out. I feel like some of these are a review of what you should already know, but I'm going to say that you don't know, because I don't know where you've come from and what you've had and what you haven't. So I'd rather just do it with you. The trick in order to get rid of e is that you have to ln both sides. And going forward, we're going to have this ln, it's logarithm naturalis, ln. And so when you see me write ln like this, that's an L, a lowercase l. The problem is that on my math lab, it looks like this, which again looks kind of like this. That is not that. It is an ln, okay? It's just lowercase l in like font Arial. Looks kind of like a capital I. So just in my math lab, it's not in, it's ln, because again, it stands for log natural base. And the natural base in particular is base e. And what happens is they e's cancel. So what I actually did here was log base e of e so that they cancel, and you're left with just this part here, okay? So e and ln cancel. That's the point of what I'm doing here. So I ln both sides so that they cancel. What I'm left with is ln of 3 is equal to 0.06 t. What I do now is I divide by the 0.06 on both sides. And that ln 3 is just a number. You just put it in the calculator. Oh, 3, not 0.3. It's 0.06 though. Calculator time. So ln 3 divided by 0.06. There's your answer. So, and that's, I think, in years. It doesn't really matter in this particular case. It's like just time units, because they're just saying find it. There was no word problem with this. It was just do that. Okay. Cool. Next problem. So 10-1-21. So this problem looked intimidating, and that's why I'm doing it. It is not a hard problem at all. And I just want to make sure you see what's going on. So there's this big table with like these formula things, and we were plugging in 100 and all this other stuff. Just look at the problem. You'll say like, it's not that bad. N equals 100. This is your formula. You plug it in. And so what they're trying to prove here, though I got to say it's really tediously bad how they are trying to prove this, is that you approach the natural base as your n goes to infinity. This is a really cool math concept. I really like how this plays out. I don't like this problem because it's just not teaching it. It's just saying plug in a number. So you plug in a number, and then you do it again for 1,000 or whatever else they're asking for. Just go to Desmos, get the decimal, there you go. But eventually this should end up with E, and that's why we're using the PERT formula at all at the very beginning, because this is compounded continuously, meaning that you're doing it all the time. We'll have the other compound interest formula pop up, I'm sure, but for now, it's just oh, look at that. Okay, moving on. So we have a 10-year CD. And again, remember this business calculus. So CD is certificate of deposit. It's kind of like a savings account where you can't pull your money out of. So you put money into it, and you bought this certificate of deposit, and then you have to wait for some amount. Here, this thing has got to wait 10 years. So at the end of 10 years, you get your money back and some extra money. In this particular case, it's a 2.03% compounded continuously, which means PERT formula. So let's do this thing. So you got 10,000. Oh, and they have to tell you, you start with $10,000 that you're going to buy this thing with for 10 years. Find the final amount. So this is just PERT formula, really. So I'm just going to remind you what the PERT formula looks like. $10,000. My rate is 0.203, and then my time is a 10. Now look at this. You see this and how I converted it? It's because you have to shift the decimal place twice, okay? You have to put it in decimal form, and decimal form for that is what you're seeing. There you go. And also think about this as like business people. Your numbers have got to make sense. A lot of times in like math, you get like a number and you don't really know if that makes sense in the particular situation. But when it comes to us, business here, you have to make real numbers. So you start with 10,000 and you're going to get 12,000 in the end. That seems reasonable. If you were to change this, and let me just put in like the wrong answer here in Desmos. Yeah, so you started with 10,000. 10 years later, you're like a quadruple billionaire. You're like, that doesn't make any sense. So, be rational about it. That's what we're doing here. The math people sometimes lose that, but you guys shouldn't, okay? Like, just for your own sake. I got $15,000 in an account, and it's actually going down. Notice there's a negative for this particular one, and they're saying, when will this now go to 9,000? Okay, so when would money be decreasing over time, right? You start with $15,000, and then how long until it's 9,000? They could be pulling money from it. It could be like debt related. I don't know in this particular case, like often in the other mathy classes, we do this with decay rates for drugs in the bloodstream. No, not those drugs. The other drugs. Radioactive decay, carbon-14 dating, all that kind of stuff. So, like, there's definitely applications, but as far as, like, money is concerned, there is down, but I don't know how to do it so simply. There's a lot more complicated down math formulas. So for right now, just solve for t. They're just saying this whole thing here, see when $15,000 will now be $9,000, solve for t. So what we're going to do is the divide ln divide strategy. This is a tried and true method to get this thing done. So I'm dividing by the 15,000 on both sides. And the rest of this problem we've technically already seen, but I just want to make sure that you understand what's going on. How do I get rid of the L or the E? Is that I ln both sides. And I'm going to ln this entire fraction. You could find the decimals for these along the way, but it's almost easier just kind of like keep it all together. Anyways, E and ln cancel. And then the last step is to divide by that tiny decimal. So divide. And do keep it the way it is. Don't try to like mush some numbers together, okay? So your final answer is kind of complicated looking, but nonetheless, here you go. So 9,000, 15,000, and all over to 0.08. Calculator, here we go. Like I already have the answer. I just want to make sure that you're seeing like I do this in Desmos beforehand. And I guess it's also just to verify that I'm getting the same numbers twice. I mean, I can mess things up, but it does happen. So, years. All right, cool. So it took 6 and some years to go from 15,000 down to 9,000. Again, this is like a decaying thing. Okay, cool. So divide ln divide. If you haven't seen it, there you go. Here's another good one. So time to double at 7% continuously. Okay, these are like really cool problems. This is a real, honest business problem. So they have some kind of a CD or something like that, and you're wanting to put some money in and see how long until it will double the amount that you started with, and given a particular rate. And that's it. It's just a formula. And really, you should be able to have a formula of this. Just like, boom, here's your formula for it. But I'll just show you how to approach this. Double means that your final amount is 2 as long as your initial amount was a 1. Okay, so I'm not saying you started with $1 and you get the $2. I mean, I guess you could, but double just means like the ratio between them is that you started with like 100% and now you are left with 200%. Okay, that's kind of what's going on here. So 2 is equal to 1 e to the 0.07 times t. And we're trying to find time, so solve for time. You don't need the 1, obviously, so we're going to start with an ln on both sides. I promise we'll get to the calculus eventually. Cancel. I'm going to divide this to the other side. And what you actually just created was a formula. It's ln of 2 divided by negative rate. And that should give you the answer. So ln of 2 divided by negative 0.07. Oh, negative? Positive? Did I put a negative in there? I don't know why I put a negative. I didn't need a negative. This is a positive. I'm sorry. I'm like, why is there a negative? I said negative. It's got to be a negative, right? No. But it doesn't matter. The number is nonetheless the same. So there you go. And this is going to be in years. So 9.9 years, about 10 years to double if you had a 7% interest rate growing thingy, which that's awesome, by the way, 7%. We really like that. At least I do. And I mean, come on. You're doubling your money in 10 years. So like whatever you put into this thing, it's doubled. You put 10,000, you got 20,000. You put 100,000, you got 200,000. You put $1 million in. Where'd you get that million from? Because I want some. 10, 1, 39. So this is a word problem, and I don't want to shy away from word problems. Whenever I see one, I'm like, ooh, that, I want you to learn, and there's often like 2 of the same thing, I find. But I want to do this word problem with you because it's excellent. And I got this one wrong at some point, and I'll tell you why here early so that you don't make the same mistake. See, this is 4.2% continuously, and it's 5.4% annually. Okay? There you go. Not continuously. And that little change, it kind of changed the whole problem here. Okay. So let's zoom out. We have $20,000 essentially, and we're putting them into two separate accounts. And they're saying that I want my total in the end to be $35,000. How much time does that take? Given that I put these in two different accounts, okay? So I believe they also say to use a graphing calculator, and that's exactly what I did for this. I used Desmos graphing. So I'm going to do that, but I need to set it up for you to have you understand what's going on. So y1, like your first function, will be this stuff here. And so I'm going to say it's 10,000 times e to the point. Oh, I put a negative there again. There I go, negatives. Negative does not belong there. 4.2%, and then times, and it's not going to be a t. You got to use an x. So we're going to say x because Desmos graphing doesn't like t. It wants an x. So there's 10,000 in the first account plus the 10,000 in the other account. Now, because it's annually, it's a little different. I'm going to show you the quick formula is that you just say 1 plus that amount, and then you just go to the dx power. So that's the quick version, but what I'm really doing is 1 plus r over n to the nt. N equals 1 for annual, so a lot of that's simplified down. So this is what I'm going to put into Desmos for the first one. The second one is 35,000, and I'm going to see where they intersect. And what I'm guessing is that it's going to be growing like this, and then there's going to be this line where they intersect at some x value, which I don't really know, but it should be at 35,000 there. So my goal is to find out what is that x where they're intersecting one another. Okay, so ooh, that was from the last time we did this. Nifty. Let's start typing this thing. So I got 10,000 e to the power of 0.042x. Again, you have to use an x. 10,000 times 1 plus 0.0454, again to the x. And that's good enough. You don't have to put the y1 or anything like that. But then if you put the 35,000, it doesn't actually work. And I'll prove it to you because I'm going to go out here to 35,000, which should be right there. And it doesn't actually do anything. So what you need to type in there is y equals 35,000. And then you can see there's my intersection point, and we're good. So that was kind of easy. So what is that x? What is that t? Is 11.79. And that's, again, in years. So there you go. I hope that later in this class we'll be optimizing a little bit more and seeing how much should I put in each account to maximize. And a lot of times for something so simple, it would just simply be dump it all into the easiest one. But you could also contend for other variables in there. So that would be a cool project in this class. But right now we're just doing homework. So 10.1.43, this is the very last question that we're going to do together. So it's talking about half-life. And again, there's not a lot of business application for this, but that's okay. So the half-life has a rate of negative 0.00023. And they say find out the years. How much time is the half-life? So a real quick on half-life, you start with 100% of something, and then it gets down to 50%, and then it goes down to 25%, and then it goes to 12.5%. The time that it takes to do each of these leaps is called the half-life. And it's the same here, and it's the same there. So what is that time to go from 100 down to 50, or 50 down to 25? The formula for it, I mean, there's just a formula for this, but I'd rather derive it with you because it's like a one-off and we're going to learn. So 1/2 1e to the rate that they give us times t. You can see there's a PERT formula here again. I'm saying half is my ending result, or 50 and 100. Again, we don't need the 1 right here, so we're going to just simply ln both sides. And what the ln does is cancel with the e. It's like we've already done this problem a lot. And I'm going to divide this to the other side. Bloop, bloop. T is equal to, ln of 0.5, because again, that's half, it's 0.5. Negative 0.00023. Bloop. Okay. Back to Desmos. I've been using a lot of Desmos here with you. Normally I just like throw a number up. I'm like, oh, this is what I got. So now you're getting your money's worth. 3013.68. Again, they want to round to the nearest year. So there you go. I think I did this one today. I can't remember. Like earlier today. Okay. And we're done. That was the end of that section. So there was really no calculus in there, but let me tell you, we're going to do some calculus next time. Thank you very much and have a great day.